So, dear children, today we are going to discuss one more topic from chapter gravitation, that are Kepler's laws of planetary motion. As we have studied about gravitational law of gravitation, that is universal law of gravitation, that there is a force of attraction between all the planets and between the planet and the sun. Now Kepler has given his laws to prove and to share his views about the planetary motion. So that's why he named it Kepler's law of planetary motion. So let us discuss one by one all these laws. So Kepler's law of planetary motion, as from its name, it's very clear that it's all about the planets, right? So let's see how it is for planet and how we can define it. So Kepler's law of planetary motion. That is Kepler's laws of planetary motion. He gave his three laws about planetary motion. So what he said in the first law, he gave his that every planet revolves around the sun. We know that is clear to all. And these planets revolve in an elliptical orbit. Every planet revolve around the sun in an elliptical orbit. I will share what is the meaning of elliptical orbit here. Right? In an elliptical orbit with the sun situated at any one of the foci. Foci is a plural word for focus, right? Of ellipse. So what do he mean by this statement? So let it be, this is elliptical orbit I am drawing. Okay, right? And then here are the two axes which we can mention with a different color. One is this, right? And one is this. So I have mentioned this with different color because that will be minor axis, right? And that we call it major axis. That is major axis. Okay. And as you can see here, the ellipse have two foci, what we can say. One is here, let it be, and one is here. Let it be F1 and another is F2. So he says that every planet revolves around the sun in an elliptical orbit with the sun situated at any of the foci. Now we can consider the sun at any of the foci. Let us consider the sun here. The sun is present and this focus F1, right? So this is the first law given by him. I am again repeating, F1 and F2 are the two foci of that ellipse. Now we can name this, we can also name this AB, that major axis AB, and CD is the minor axis. CD is the minor axis, right? Sun is present at the focus F1. Okay. Now, then he gave his second law. What he said in his second law, very interesting. He said in this elliptical orbit of the planet, the line joining the center of the planet to the center of the sun, the line joining the center of the planet, line joining the center of the planet to the center of the sun, to the center of the sun, right? Sweeps out equal areas, in equal intervals of time, in equal interval of time. What I mean by this? Now let us consider another planet. One planet is revolving around. Let one time planet is present here, right? And after some time, the planet come here, right? What I mean by this? Now the line joining the center of the sun to the center of the planet, center of the sun to the center of the planet. These are the two lines joining these. Now, dear children, you can easily identify there is a region formed by this. A particular, what I can say, the shape. This shape I am telling you, right? This one. So full area, the full area formed by this, like here. This complete region. It's a kind of triangle you can see, right? So this is a kind of triangle. Okay. And we know that this will have the area also, right? Let this position is P1, this position is P2. Okay. Now, according to the law, let the planet now is at any position here, and then after some time it's coming to here, right? Again, what we will say, we will draw the diagram again, that center to center line join karenge iski. So these are the center to center line join. Again, now the area, this is another area formed by this same planet in the same time. The one thing which is need to be noted, that is the time will be same in both the cases. Let this is the position P3 and this is the position P4. Now, according to Kepler's law statement, what he says that let this center, isko bhi assume kar lete hain, let this center is O. Now, according to this law, area of OP1 P2 will be equal to area of OP3 P4. This is the second law of Kepler's. So I'm again repeating, see, the time will remain same, T, here also, T, right? So according to Kepler's second law, in elliptical orbit of the planet, the line joining the center of the planet to the center of the sun sweeps out equal areas in equal intervals of time. Dear children, this is the line joining. This is the line joining the center of the sun to the center of planet, right? Now, if I will assume this after time t, this line will come here, right? So when it will reach that position P2, it will cover some area. We can calculate. Same happens here. This one and this one. Again, the area is formed when the object is at position P3 and P4. Now, this area will remain same. But The thing is that time should be same. That means the time taken to move from P1 to P2 is the same as from P3 to P4, right? So this is Kepler's second law. Okay. Now the third law given by Kepler. According to third law, he says that we know that the planets are revolving around the sun. So the scale of time period of revolution, of a planet, right, around the sun, is directly proportional to the cube of semi-major axis, right, of elliptical orbit. What is the meaning? That means let t is the time period. Okay, one revolution, so that scale is equal to r cube. R cube kya hai? Semi major axis. This I told you that full A to B is major axis. Semi means yeah, right? So this region will be semi major axis, right? Let it is x. So B to x or xb is the semi major axis. Or what I can say about this, r cube by t square is constant. That these two are constant, right? Now we can say that the planets which are nearer to the sun, right, they are moving faster. This area is larger as than this compared to this because they are moving faster when they are closer to sun. Kepler stated only the laws of planetary motion, but he could not give a theory to explain the motion of planets, right? That's why it's mentioned in the NCERT book in a colored box, because he could not give the theory to explain the motion of planets. It was Newton who established that the real cause of planetary motion is the gravitational force that is exerted by the sun on the planet. Because Kepler said about these three laws, that they are moving in the elliptical orbits and they are sweeping out equal areas when we are taking the same time. And third, the time period scale is directly proportional to the cube of the semi-major axis. But he was unable to explain that why these planets are revolving like this, why they are not moving somewhere else. So that was the Newton who gave the full explanation. Yes, that there is a force which exists due to which the planets are revolving around the sun, and that force is the gravitational force, which is attractive in nature, right? And he gave his Newton's law of gravitation, which we have already done, right? So thank you so much. I hope this video is going to help you out to understand the planetary motion given by Kepler.